we have seen about security attack. In this presentation, we are going to see security services. In the next presentation, we will see about security mechanism. So in this presentation, we are going to see about security service. As per Request for Comments RFC 2828, we have this definition. What is a security service? It is the processing or communication service that is provided by a system to give a specific kind of protection to system resources. Security services implement security policies and are implemented by security mechanisms. I hope the definition is a straightforward one. We understand that obviously we are going for security in order to protect the system resources. Now, in order to protect the system resources, we can understand that in order to provide security services, we need to implement certain security policies. How these policies are then implemented? These policies are implemented through security mechanisms. So ultimately, in order to protect the system resources from attacks, we need security services. Actually, these security services implement security policies, and these policies are implemented by security mechanisms. As mentioned, this is the definition available in the Request for Comments 2828. Let's see the various security services that are offered by the secured system. Basically, there are 5 security services. The first security service we would like to address is the authentication. What is this authentication? Actually, this is the assurance that the communicating entity is the one that it claims to be. Suppose if the communicating entity is claimed to be Alice, then authentication says that Alice only is accessing the data item or Alice only is accessing the system resources. In simple words, authentication proves the identity of the sender. Suppose if the sender is claiming to be Alice, then authentication mechanism proves that only Alice is accessing the system. If someone else is accessing the system resources, then this authentication mechanism will find out that Alice is not accessing the system. So we need authentication in order to ensure that the right entities are involved in the conversation or right entities are accessing the system resources. Talking about the authentication, we have 2 types of authentication. Number 1, peer entity authentication, and number 2, data origin authentication. Let's see an example. It will be more clear for you to understand what is peer entity authentication and data origin authentication. In this example, we know Bob is going to send some data to Alice. So here the sender is Bob and the receiver is Alice, and we know they are communicating through the internet or other communication facility. And in this example, we have Darth. In order to talk about this authentication, suppose if Alice is receiving a message from Bob, Alice should confirm that the message is actually from Bob and not from Darth. How Alice will find that? Alice will use the authentication service in order to ensure the message is from Bob only and not from anyone else. So this is actually authentication. Talking about the peer entity authentication and the data origin authentication, we know in the internet there are lots of nodes involved. Let's assume there are 2 routers that are connected to each other. When the first router is going to forward the data to the next router, that is its neighboring router, the neighboring router should confirm that the data is from its neighbor only and not from some other routers. If an attacker is able to inject his own router, and that bogus router may be a part of the network, and all routers may start trusting that bogus router. We need to ensure that authentication is taking place. So whenever a bogus router is inserted into the network, our network should be able to identify that and the authentication fails. So this is actually peer entity authentication. And coming to the data origin authentication, in this example, Bob is going to send the data or message to Alice, and when Alice receives the message, Alice should confirm that the message is from the source Bob. So this is called as data origin authentication. We are done with the first security service, the authentication service. Let's now move on to the second service, the access control. This access control is going to control the access. For example, in the network, we may have a lot of system resources. Who can access what kinds of resources must be established. For example, in a banking environment, a teller has a lesser privilege than the manager. Teller can access only few resources in the banking environment when compared to the manager. Though the teller is an employee of the bank, but still, teller has lesser privilege than manager. So every user must be associated with the levels of privileges and the levels of access. This is what we call as access control. This is about the second service. Let's move on to the third service, which is data confidentiality. We need to ensure that the data is confidential and the data is protected from unauthorized access or unauthorized disclosure. Let's see an example. In this example, Bob is going to send some data to Alice. Obviously, we should ensure that no one else, including Darth, can access the data items. Say if Bob is sending some data item and if this data item is being captured by Darth, Darth should not be able to know what is the message. When Bob sends an encrypted message, only then Darth will not be able to see what is the message. If Bob sends plain text just like that, Darth will be knowing what is the data that is being transmitted between Alice and Bob or Bob and Alice. So before sending the data, we expect the system to do encryption. So encryption is one of the ways we can achieve data confidentiality. So this is about data confidentiality. In order to achieve privacy, we need encryption, and encryption is an example for data confidentiality. And this data confidentiality can be achieved through many ways, and encryption is the most popular method. We are done with the third security service. Let's now move on to the fourth service, which is data integrity. What is this data integrity? Already we have seen this in the CIA triad. Data integrity means whatever the sender is sending, that only receiver should receive. So sent is equal to received. Say in this example, if Bob is sending some data item to Alice, whatever Bob sends, that message only Alice should receive. So there should not be any modification or insertion or deletion or replay of messages. There will be attackers on the network and they will insert new data items, or they will modify the data items, they can delete the data items, or they may replay the data items. So our system should ensure that it is providing data integrity as one of the services. So that's the fourth security service, the data integrity. Let's see the last security service, which is non-repudiation. Before understanding what is non-repudiation formally, we will see non-repudiation with an example. In this example, let's assume Bob is sending some data item to Alice and Alice has received the data from Bob. Later, if Bob denies that he has not sent the message, the security system should prove that Bob only has sent the message. Not only that, when Alice receives the message, after receiving the message successfully, Alice should not deny that she did not receive the message. So security system should ensure that after sending or receiving, denial of messages should be handled. If any of the entities denies that they have not sent or they have not received, it should be proved that they have sent or they have received. So this is about the non-repudiation. We will see the definition. We will see it formally. Non-repudiation provides protection against denial of one of the entities involved in a communication. Normally there will be sender and receiver, right? So normally non-repudiation can be at two levels. One is at the source level and the other one is at the destination level. In the source level or in the sender level, there will be proof that the message was sent by the specified party. Like the source level, we also have non-repudiation in the destination level or in the receiver level. So there will be proof that the message was received by the specified party. So as far as non-repudiation is concerned, we should have proof that the message was sent or received by the specified party. And that's it, guys. I hope now you understood the various security services such as authentication, access control, data confidentiality, data integrity, and non-repudiation.